Today, we're going to discuss the fundamentals in physics that is useful to understand the concept of space exploration and orbits. Mr. Cheng, a physics teacher from College Islam Kelang, will do some experiments to demonstrate the concept of free fall and microgravity, twisting orbital platform and spinning objects, surface tension, and Newton's laws. Okay, let's meet Mr. Cheng in his laboratory and listen to his explanation on free fall and microgravity.
I drop a heavy object and a paper. Which one will reach the ground first? The jar. Okay, now we shall see. So, which one reach first? Container. Now this is due to air resistance. Let's see if we reduce the air resistance on the paper and we do the experiment. Just see. This time are the two objects, the paper and the container, fall at the same time? Yes. So it is not due to the weight. And I shall show you these two things. Now, these two paper, they are of the same weight, right? If I drop, which one will reach first? The scrap paper. Why? Because it has lower air resistance. On this table, there are three different slotted weight. One is 20 gram, one is 50 gram, and one is 100 gram. I drop all this at the same time. You listen to the sound, they touch the ground. Okay? You only hear one sound, right? Yes. You only hear one sound. It shows that all the three objects fall at the same time, although they are of different mass or weight. Now, we shall see what happened to water and the container. Are they going to fall at the same time also? Now you see, just watch carefully. Okay, the water and the cup falls at the same time. Now you have a bottle. All you have the bottles. Can you take the bottles up? These bottles can contain some holes in it. So now I want you to fill up the water. The water is leaking in it. Yes. You see, the moment I drop, you see the water stop coming out. But the moment I hold it, it comes out. What does it show? Before, the water doesn't exert any pressure on the wall of the vessel. And another experiment I would like you to do is this. This is a weight. Okay? This is a rubber band that will pull the paper away. Okay. I put this on the table and pull the cardboard and place it with the cardboard. Okay, now, does the paper move? No. If the paper doesn't move, the weight is pressing the paper against the plank. Now, I shall drop this. I shall drop this, and you see at the moment, my hand is not touching the board. You see what happens? The paper was pulled out. It shows that the weight is not pressing the paper against the plank or the supporting board. Now, what if you put more weight? The same thing. I jump up. The moment my legs leave the floor, you see. The moment my legs leave the floor, you find that the paper come out. Okay? So if I jump up, the only force that is acting on me and all this object is the gravitational force. No other force acting on it. Now this is a weighing machine with a very heavy weight on it. So, does it read the weight? Okay, now, the same thing, I will drop the thing. The moment it drops freely, without touching my hand, you look at the pointer. Pointer, okay? Ready? 0. What do you see? 0. It went to 0, isn't it? Yes. Or I throw it up. Okay? The moment it leaves my hand, I throw it up. At that moment, what do you see? 0. Or I jump up. I jump up. I jump up or jump down here. I jump up. The moment my legs leave, okay? What do you see? 0. It went back to 0, isn't it? So, when we are in free fall, the weight doesn't exert a force on the weighing machine. Therefore, the reading of the weighing machine will be 0. Imagine when you are in a lift, standing on a weighing machine. If the lift suddenly snaps, the cable of the lift suddenly snaps, and imagine that if there's no resistance, that the lift and you will be undergoing free fall. Then there will be no reading on the weight machine. So the reading of your weight will be 0. We call this phenomena small thumbtack and your marker pen, the sharp tip. Now, you all should try to make it stand. See whether it can stand or not. It has a pointed end, so it is unstable. Can you try to spin them and see what is the effect of your spin? Is the top spinning? Yes. Because you give it a high rotational and energy, then it can stand up. Okay? So you look at the tops. After some time, what will happen? It will fall, okay? But you fall, why? Why does it fall? Because energy is dissipated due to friction. Boys and girls, this is the model of the top that our Angkasawan will be using in the ISS to do the experiment, to show it to you. Okay, now I shall spin this with the axis vertical. Okay, what do you see? The spin axis remain what? Vertical all the way. If it's not spinning, I throw it the same way in a projectile on Earth. You see? The top thumb goes. I will spin the top and force it to go almost horizontally. so that or the direction of point at an angle. Okay? Okay? You see all the way the spin axis point in the same direction until it touches the ground. You have seen how you can make an object stand by spinning. But what is the criteria for a good spinning object? Can you give me? Symmetric? Symmetrical. 2. It has big diameter. Okay.
Surface tension is the tendency of liquids to reduce their exposed surface to the smallest possible area. A drop of water, for example, tends to assume the shape of a sphere. This phenomenon is attributed to the cohesion, that is, the attractive force acting between the molecules of the liquid. Now, let's listen further to Mr. Cheng's explanation on this subject.
Now, boys and girls, now we will see how the physical property of water affects its shape on Earth and in the orbit. On Earth, water has to be held by a container. In a free fall or in ISS, the surface tension of water causes the water to form a sphere. Okay, water molecules have cohesive forces. They attract one another. So it has a resultant inward force to pull all the molecules in, thus expose the minimum surface area. For a volume of liquid, for the same volume, sphere has a minimum surface area. So the attractive force between water molecules or liquid molecules will pull all the molecules in to form minimum surface area. Therefore, it will form a sphere. So in ISS, the sphere can be very big. There's adhesive and cohesive forces between molecules. The cohesive forces are forces of attraction between the molecules, whereas the adhesive forces are attractive forces between different types of molecules. So when adhesive forces are greater than the cohesive forces, the area of contact between two types of surfaces increases. And when cohesive forces are greater than adhesive forces, the area of contact between the two types of surfaces decreases. So when you see on Earth, water will wet the glass because the adhesive force is greater than the cohesive force. We should now do experiment on surface tension. On your table, there is a gas trough half filled with water, and you have your petri dish and a shaving blade and also a paper boat, model of a paper boat, and this is your lycopodium powder. Fill this petri dish with water. Okay. After that, you will place your shaving blade. Okay. And put it on a tissue paper. On the water. Okay. Shaving blade floating on top of the water. because the water appears to have a skin. Actually, this skin is caused by surface tension. Now, see what will happen if we drop some soap solution into the water. So, soap solution can weaken the surface tension of water. If we turn the tap slowly and let it drop, let the water drop, you find out the moment the water drops, the surface tension and the cohesive force within the molecules will try to pull all the molecules together. So the water droplets become spherical in shape. The next experiment is we try to put lycopodium powder on the surface of water. Okay, you see I put this without soap solution. I place it at the center. You see what happened? Very little. Now we dip the pin in soap solution. Lycopodium will just pull away to the side. It shows that this soap solution weaken the surface tension of water, just like you punch a hole in your balloon. The skin of the balloon or membrane of the balloon pull away. Okay, now we have a paper boat. You place this on top of the water. It's floating on top of water. Now you just take, I put the soap solution at the hole there. The group just glide forward. Because at the back of the boat, you weaken the surface tension. The surface tension in front of the boat will start to pull it. That's why the boat moves forward. The bubble has two surfaces because it has a very thin liquid on both surfaces. The first surface tension will try to reduce the area exposing to the air, so it starts to form spherical shape, because for the same volume, sphere has minimum surface area.
Sir Isaac Newton and his laws of motion and his works on various fields of mathematics have helped us to shape the modern science that we study today. Newton's first law of motion states that if the net force acting on a body is zero, then it will stay at rest, if the body is at rest. But it will keep on moving at a constant speed in a straight line if the body is moving. Now, let's listen to Mr. Cheng's explanation on Newton's first law.
We will demonstrate Newton's first law, which is also called the law of inertia. You look at the marbles in this cylinder. How does the marble behave when I move the cylinder suddenly? The marble remains behind, and due to gravity it falls down. If I move this marble and suddenly stop, the marble will move forward. What is this law? Newton's first law. What does Newton's first law state? That a body will remain at rest or uniform velocity unless acted upon by an external force. Another thing is experiment that I want you to do. come down. What causes this? Gravity. Because it goes up, it will slow down and come back and speed up because of gravitational attraction. So, thank you, boys and girls.
We have learned about free fall and microgravity, twisting orbital platform and spinning objects, surface tension, and Newton's law. I hope that what we have learned today would interest you to understand the fundamentals in physics. The fundamentals is useful to help you to understand the concept of space exploration and orbits. Thank you.